So this is the capstan that holds the coiled steel. The machine requires coiled steel. That might be raw or it may be pre-coated. It's really at its best with pre-coated steel, particularly if you can save the paint finishing, because you don't need the cost of a paint line. At each capstan, 2 tons. On this particular machine, the maximum working width is 800 wide. It suited most of our needs. We would load on here, this would be clamped hydraulically, press a button, capstan turns round to the work position. Whilst it's working, the operator can load another coil. So in that sense, very, very straightforward. Here, an Italian decoiling machine and leveling machine. And that would be, we'd be governing the amount of pressure that we're applying to make sure that the coil is flat. The last thing you want is coil that comes off like a ploughed field. That's no good at all. This dancing arm here allows the material to sweep down. The dancing arm controls the feeding of the coil, and that will then make its way up here. At this point, we have 2 opposing punch heads, small ones. Now, it could be that you have a common notched form, such as that you might have on, let's say, modular shelving, where you'd have a series of notches which the horizontal arm would carry to engage with the vertical. Those forms could be in here, and these fellows would be punching away, giving you that common form. Conversely, we often make products which are in family series, so that rather than buying a coil, say at 550 wide, and needing a lesser quantity at 500, you might use these heads to reduce the coil to 500 wide, because actually it'd be financially more viable given that you're using the 550 stock, which you're buying more cheaply. Either way, those can be called up singly or doubly as required. This fellow gives us control of the x-axis, which is the length. Working tolerances are plus or minus 0.1 of a mil, so at 4/1000ths of an inch, that's pretty good. So following that, we've got 2 opposing punch heads. These are controlled together. They can work separately if required, but uniquely are capable of crossing the center line of the coil. The PLC makes sure that these fellows don't have an accident. They do not collide, so that that head is capable entirely of coming way across the center line and bringing tools to bear on that side of the material. Now, if we look then at these carry punch cassettes. The cassettes look like this. Here you can see, large and small, we've got 2, 4, 6, 8, 10 punches. So it's punch, die and stripper, return spring. These 2 fellows can be set up whilst 2 more, one in here and one in there, are in working, so that you can change over very quickly. Now, having punched the strip to the configuration that you want, this is a cropping head. It's a guillotine. It cuts very finely. So unlike a CNC turret punch, where even with a quality punching machine, you've still got a slight notching to the edge, the slitting at the beginning of the coil, which is what you're buying in, and the guillotining to length means that in terms of the rectangle, both the longitudinal edges and the transverse edges are all straight and clean. There are no notches. So in a sense, you could have your cake and eat it. It could be that you're using pre-coated steel or raw steel, but either way, that material can come along here to meet the stop. And then if you want to discharge at that point, this is a scissor lift. You can see it's down at the bottom at the moment. That can come up and will be chased down as it's loaded. So the parts come through what the manufacturer in Finland calls the bomb doors. Those bomb doors will open and it will go into the stack. If you're wanting longitudinal bending, the part will come this way along the conveyor to the wing benders. The automatic gripper will collect the edge of the sheet here, carry the sheet forward into the machine, and this part will collect and go into the wing bender. Now the wing bender will fold and fold and fold the detail required. If you want to bend then on the other side to form, say, a channel or shelf, then this will collect the sheet, take it to the opposing bender. Same thing will happen. One or two or more bends will occur, and then when finished, this will come back out. The gripper will collect it, put it onto the conveyor, and deliver it to the operator. Now, these wing benders are configured in such a way that if it was a pre-coated steel and with good housekeeping, we can bend without splitting the film and without marking it. So if you were to look very closely, you would not be able to see any marks. It doesn't really require engineering plastics to do that. You can get tools that have it, but with wing bending, it's a very, very good process. We can also do safety edging as well. If it's pre-coated material and the edge is seen, then normally the design would require you to fold the cropped edge out of sight, and that would be the good practice. Both German controllers, Siemens Numeric 810M. This machine, we would change this machine as many as in a single shift, we could do it 10 times. I don't want to do that because I'm a classic engineer. I don't want to pander to the customer. I want to do 10 million things all the same because it makes for an easy life. But actually, as a coil line, it's more flexible than you might think. We don't have to put on 1.5 tons of metal and consume it. We would put the width on, run an amount, generate cut from the guillotine, which is down there, put the decoiler into reverse, wind it back, tie it off, and we would take the coil off. Sometimes we might leave a coil on, we might turn the coil round and leave it at the other station for production in 2 days' time and bring it back on again. So we did move to just-in-time production. But certainly, if you're producing longitudinal components like channels or shelves, this is an absolute killer. It really, really is. I think the disadvantage would be you need a remedy for finishing the short edges if you're wanting to do a fold, and under those circumstances, it would go elsewhere. But if you look at the economies of buying coil per square meter should logically be cheaper than sheet simply because the mill already charges you for decoiling product from the mill and producing sheet. But equally, even with our laser, you want 2.5 meter sheet on a particular job and you've only got 3 meter in stock. With this, it doesn't matter. Clearly you've made a decision on working width. But this process is really good. Not only would we be punching, by the way, but we would be both punching and coining. So we could actually not only punch a hole, but we could strike it with a counter punch, which saves counter sinking, which would be really, really good. Equally, we might draw the material. Now, if we draw the material on the punch, that was very, very helpful because we know if we were using an M6 coarse, ISO coarse thread, so a 1mm thread pitch, if we could draw the material and get maybe up to almost 4 threads for tapping, then even if we had 40 threads, the performance would be no better at 40 threads than it would be at 4 good threads. And we were able to punch and counterpunch and draw material that later could be tapped. So all in all, it made for a very good job for us. A very, very good job indeed.